Okay, so we'll be discussing the today's Leetcode contest, and I have solved the first three problem. So I'll be discussing that those three questions. Like I'll be discussing the problem from the end. Let's take the third question first, and then we'll be discussing second question and then first question. Like I have not solved the fourth one. I will try to absolve it, and then yeah, we'll discuss that later. Okay, so what has been asked in third question is that if you have been given one grid, right? You have been given one grid, and you have been given one vector of vector. Okay, so like grid of n cross n dimension, and you have been given one vector of vector which basically contains the dimension of the rectangle. So like you can see the first case here. There are one, two, three, four rectangle, and then their respective dimension is here, and this is 5 cross 5 grid. Okay, so like this is the first rectangle L01, whose starting point is 1 comma 0, and diagonal point like this has been given as the 1 comma 0 is the this point, and 5 comma 2 is this point. Okay, so like diagonal points are given. Now we can also see this second rectangle. Which one is second rectangle? 0 comma 2. Yeah, this is the red one is the second rectangle, and third rectangle will be this green one, and yeah, blue one is the fourth one. And like we'll have to do two type of partitioning here. Either you will do the horizontal partitioning or you will do the vertical partitioning, right? And you have to tell, if I'm doing this partitioning, then can we divide the grid into three part? Obviously we are doing the partitioning two times, so like it will divide the grid into three part, but you will have to ensure that all those three part must contain at least one rectangle. Okay, so let me elaborate all these things with the help of this diagram. Okay, so like there is a grid. Okay, there is a grid, and there are some rectangles. Okay, so let's say my drawing is not that good, so sorry for that. Okay, so let's say this is the first rectangle, this is the second rectangle, and this is the third rectangle, and let's say these are the rectangle 2: first, second, third, fourth, fifth, sixth. And like one more condition is there, like you don't have to partition the grid in such a way that it will cross through any rectangle, right? Like as you can see here in note, that the rectangle do not overlap. Yeah, and also there is another condition is that the rectangle do not overlap. It has been granted by the problems setter here, and like you'll have to determine that either two horizontal or two vertical cuts on the grid, such that each of the three resulting sections formed by the cuts contain at least one rectangle, and every rectangle belong to exactly one section. Okay, so I mean, what does this question mean? That let's say this is the first partition I'm making here, and this is the second partition that I'm making here. So like you can see, this partition consists of two rectangles, right? And this partition is also consisting of two rectangles. These two rectangles. So like I have divided this whole grid into three parts: the first part, second part, and third part. And this part consists of two rectangles. Similarly, this part consists of two rectangles, and this part consists of two rectangles, right? So like we'll have to do the similar thing we can do horizontally. Like if we'll divide the we can do the things horizontally. Like let's say this is the grid. mm, let's say this is the first rectangle, second rectangle, third rectangle, and fourth rectangle. Okay, yeah, like here we can't partition the grid into three part. Like we can't make any partition, because if we make the partition here, then this line is passing through this rectangle. Like we can't do this thing. And similarly, if we'll partition this grid into try to partition the grid, then this line passing through this rectangle, which is not possible. So yeah, like you'll have to keep this thing also in mind. And let's say this is the this is the first one, this is the fifth one, and this is the sixth one. Then we can partition the grid into the three parts, and every partition, like I was talking about the horizontal partitioning. Yeah, actually I have did the vertical partitioning again. Okay, let me erase it first. Okay, let me take the new page. Like whatever I have described about the vertical partitioning, we can do this. We can do same thing in the horizontal partitioning as well, right? So like you can see here, mm, yeah, like you can do the horizontal partitioning in this way, such that let's say these two partition has divided the grid into three part: the first one, second one, third one, and all the partition consists of at least one rectangle, right? And this is the example of horizontal partitioning. If we'll divide the grid, partition the grid in this way, then the every partition consisting of at least one rectangle. So yeah, these are the condition, and this is the question. And like if you are able to divide the grid into three part and every part consists of a rectangle, then you are okay, and you will have to return the true. Otherwise, you are not okay. In that case, you will have to return the false. Okay, so like how we can approach this question? Actually, like I will be discussing how I have approached this question. Okay, so this was the grid. This was the grid, and let's say, like first of all, we'll be discussing about horizontal partitioning, and then we'll be discussing. Then we can relate the same thing with the vertical partitioning, and then we are done with the question. Okay, so let's say this is the first rectangle. This is the first rectangle that we have. Okay, and let's say this is the second rectangle that we have. Actually, I have understood this question via this example only, and that I want to elaborate it here again. So this is the second rectangle, and let's say this is the third one. Okay, and let's say this is the fourth one. This is the first one, this is the second one, this is the third one, and this is the fourth one. So how we can do partitioning here? Like how we can partition the grid into three part such that every part consists of at least one rectangle? How we can do these things? So like can we do partitioning here? Here can we do this thing? This is completely this is restricted here. Like we can't do this thing, right? So we can't partition the grid like this way. So this is not the proper way to partition the grid, right? Okay, so here we can't do the partitioning. Can we do the partitioning here at this point? I think we can partition the grid at this point, and similarly we can partition the grid at this point. Okay, because this partitioning is not passing via any rectangle, and also yeah, everything is satisfying. So like we have divided the grid into three part: first part, second part, and third part, and every part consists of at least one rectangle. So we are okay with this example, and then in this case we will be returning true. And like we can do the similar thing for the horizontal partitioning. hmm. So I think we have understand what we have to do, and now let's move toward how we can do. Okay, so mm, this is the grid, and like this was the test case at which we are trying to understand. mm, okay, so this is the first rectangle, this is the second rectangle, this is the third one, and this is the fourth one. Like we can't partition the grid at this moment, right? We can't do this thing, or we can't even do this thing as well. Like we can't partition the grid at this point. Okay, so like where we can partition the grid? We can partition here, or here. So let's say this is the starting x coordinate of this rectangle, and this is the end x coordinate of this rectangle, and similarly this is the starting x coordinate of this rectangle, and this is the starting end x coordinate of this rectangle, and also this is the starting x coordinate of this rectangle, and this is the end x coordinate of this rectangle, and similarly this is the starting x coordinate of fourth rectangle, and this is the end x coordinate of fourth rectangle, right? So like on the basis of x coordinate only, if we sort the x coordinate, like let's say like we can if we sort the x coordinate, then we'll get the rectangle in this way. Like this is the this is the much closer rectangle to the origin, right? Let's say this is the x coordinate, and let's say this is the y coordinate. Then this rectangle is much closer to the origin, right? So like this rectangle will come first, and then this rectangle will come first, and then this, and then this. Okay. So first of all, if we are concerned for the horizontal partitioning, then uh, we'll try to solve the question on the basis of x coordinate of all the rectangle, the beginning x coordinate of the rectangle, and then end x coordinate of the rectangle, of each and every rectangle, and then we'll sort it, and then uh, we can see that this rectangle will come first, and then this, and then this, and then this. Okay. So like if we are concerned for the horizontal partitioning, then we'll play with the x coordinate, and then we'll sort the x coordinate in order to get which rectangle will come first, and then which rectangle will come second, and then third, and then fourth one, right? So here we have got that this rectangle will come first. So like at the end of the first rectangle, can we do partitioning? No, we can't do partitioning. Okay. So where we can do partitioning? Either we can do partitioning here or here. So don't you think this x coordinate is greater than this x coordinate? Okay. See, this x coordinate is greater than this x coordinate, whatever the end x coordinate of this rectangle, right? So if there will be two merged rectangle, in that case I will be taking the maximum of the end x coordinate of both the rectangle. If they are not the merging rectangle, then we can do the partitioning there. Like we can see here, this rectangle and this rectangle are merged one, like these both are merging one. So like we can't do partitioning here, right? So where we can do partitioning? We can do the maximum of end x coordinate of this rectangle and end x coordinate of this rectangle. We can do the partitioning at this moment, at this point. Okay. So at this point we can do the partitioning, and here we can see these two rectangles are not merged. So yeah, we are good to go. At this point we can do the partitioning, and similarly here at this point these two rectangles are not merged, so like we can do the partitioning again at this point. But here these two rectangles are merged, so we can't do partitioning here. And similarly here we can't do the partitioning at this these two point here and here, right? So like if both the rectangle, if any two adjacent rectangle are not merged, then at that point we can do partitioning. If they are merged, then we will take care about where we can do the partitioning. Where we are able to do the partitioning? At the maximum end coordinate of both the rectangle, both the rectangle which are merged, right? So this was the end x coordinate of this rectangle, and this was the end x coordinate of this rectangle, and which is the maximum one? This is the maximum one. Like we can't do partitioning here, we can do partitioning here. So like if we are concerned for the horizontal partitioning, then we will always take care about these things. And similarly we can do for the vertical one. Like you can relate these things by taking some test cases. Like I'm not going to elaborate that things. Like if we'll draw this type of rectangle vertically, then you can understand what I'm telling, right? And then okay, so let me show you the solution. This was the first one. Okay, and this is the code that I have written. See, this is the vector of pair that I will be maintaining again, like here in this question, that will be x and y coordinate of each and every rectangle. So this is the starting x coordinate of the rectangle, and this is the end x coordinate of this rectangle, of the rectangle. No, 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 no. This is the starting x coordinate of the rectangle, and this is the end x coordinate of the rectangle, and similarly this is the starting y coordinate of the rectangle and this is the end y coordinate of the rectangle. And then I will be taking all those things, all those coordinate in x and y vector of pair data structure, and then we will sort in order to get which rectangle are coming at which position, and like sorting making sense here, right? And we will be taking the first this like this coordinate. I will take this coordinate, I will take this coordinate, and then we'll start from the second rectangle. If this coordinate is greater than equal to this coordinate, then we can do partitioning. Like here these two rectangles are not merged, but if they are not, then we'll have to maintain who is the maximum among this coordinate, this coordinate and this coordinate, the end x coordinate of this rectangle and end x coordinate of this rectangle. So yeah, that thing I have done. Like if x of I dot first is greater than equal to val1, which is the previous coordinate of the rectangles, previous end coordinate of the rectangle, end x coordinate of the rectangle, then yeah, we are good to go, and then we'll increase the count. Like we can do the partitioning here, and we'll always be maintaining this maximum of val1 comma x of I dot second, and similarly we'll be doing it for the vertical one. And if we are able to make the partition more than two times, then in that case we are done, and in that case we'll be returning the true, otherwise we'll be returning the false. So yeah, this was the question and this is the solution. Like you can observe it here, and I think I am done with the explanation. Okay, so this is all about the third question, and let's move toward the second one. So in second question, you have been given one grid. You have been given one grid, and let me elaborate it here as well. Like you have been given one grid, okay, and then we'll have to start your traversal from let's say this is a 3x3 grid, and we'll start your traversal from 0 comma 0, and then you'll have to reach at this coordinate, that is n minus 1 comma n minus 1 m minus 1. At this point we'll have to start your traversal from 0 comma 0. So you'll have to tell how many paths are there. Like we have been given the cell value, you can see count the number of path or what. Okay, so like this is the grid. Actually the grid with the value are given here. Okay, this is 3x3 grid, and the value of each cell have been given here, and there is another code, there is another integer that is 11, that is k, and you have to tell how many paths are there to visit from 0 comma 0 to n minus 1 comma m minus 1, right? Such that the jour of all those paths that we have followed in order to visit from 0 comma 0 to n minus 1 comma m minus 1 will be exactly equal to k. So and then you can do the two type of traversal, right or down. Okay, so like you can go from here to here, here to here to here to here, like in this way, right? Or there is another path here, or there might be this path. Okay, like there are a lot of paths, and then you have been given the value of each and every cell. You have to tell, is there any path from 0 comma 0 to n minus 1 comma m minus 1 possible, such that the jour value of all those value in the path will be equal to k. Is it possible? If it is possible, then you will have to tell how many paths are there. So I think this is the simple question of DP on grid. Like what we can say, let's say this is the 3 cross 3 grid, and like we are starting from here, we can go at this cell or we can go at this cell. Like I have two choices, either we can go right or we can go down. If I am going to this cell, then I will take the jar value, jar of, like I will initialize the value of jar with 0, and then I will take the jar with this, the value at this cell, and then I can go this to this cell or I can go to this cell. I have been given the two choices here. Okay, and suppose if I'm at this cell, and like if I'm at this cell and this cell also contains a value, so I will calculate the overall jar at this cell, and then I can go to this cell or this cell. So like I can go to the right or we can go to the down. So these are the possibility here. And if I am at this cell like n minus 1 comma m minus 1, then I will check if the jar value equal to k or not. If it is, then I will be returning 1, and if it is not, then I will be returning 0. So these are the choices. Like what is dp of I comma j represents? Dp of I comma j represents, like we can't understand this way. Like if I'm at any cell I comma j, if I'm at the any cell ith cell I comma j, then I can go to its right or we can go to its down, right? Like I will have to visit to the cell n minus 1 comma n minus 1 with the jar value equal to k. If we are able to do, then yeah, there is one possible path. Okay, so if I'm at ith cell with some value k, then what is the number of if I'm at ith cell I comma jth cell with the jar value k, this represent I'm at ith cell with I'm at I comma jth cell with jar value k, and then there will be certain number of path possible. Actually, like we can't relate in this way. Like we'll have to do the recursive, we can write the recursive code here. Like we can initialize our recursion from this cell, and we can go to n minus 1 comma m minus 1 via following all possible path, right? And like I will be calculating the jar for each and every cell. And if I'm at this, if at the moment if I'm at this cell, then I will first of all I will check if the jar value at if I have reached at this cell, if the jar value is equal to k or not. If it is, then I will be returning 1, otherwise I will be returning 0. Okay, so like yeah, this was the uh, explanation for this question, and like you can see the code here. What I am doing, if I am outside the grid, then like there is no any chances, there is no possible path, right? Otherwise I will be calculating the jar of each and every cell of the grid, and then this is the base case. If I have reached at the destination, that is n minus 1 comma m minus 1, then at that moment I will be checking if the jar value at that cell is equal to k or not. If it is, then I will be returning 1, otherwise I will be returning 0. And then this TP I have used for the memorization, and these are the two possibilities that I can follow here. And like I will have to calculate the total number of path, then I will be doing the right plus down. Okay, so I think this is the solution of the second problem, and now next move to the first one. So like first one is very easy question. We'll have to select the subarray of length 3 such that the first and third element sum will be equal to the half of middle one. So in this case, this is the subarray 1 for 1, and the summation of first element and the third element is equal to 4 by 2, right? So this is the one possible subarray, and in this case it is 1. We can't find any other subarray following these properties. In this case also like we can't do. Let's say I have selected the whole array, and summation of first and third is 2, and the half of middle is 0. So like we can't do this thing. Hmm. So simply I will have to check, like I have found the first one and then middle one and then last one, third one. If this condition is satisfied, and one more condition, like middle must be even, otherwise you can't do. Let's say mm, so this is the test case. Summation of first and third is 2, right? While the middle by 2 is also 2. But is it? In this case it is true, but the twice of this 1 plus 1 is not equal to 5. So like this is not true. Like I have made one wrong. uh, I was not able to observe this thing. The middle one must be even, right? So if middle one is even, then only we can do the things, otherwise we can't do. And then at the end we'll have to return the count. So yeah, I think this is from my side, and we have discussed the all three problems. So yeah, thank you.